number 4. So number 4, I'm going to read it out loud here. A ball is thrown upward. So notice in the previous problem, we had a ball kind of just plopping down, right? This is our building, and the ball is popping down. Here in this case, a ball is being thrown upward. Let's see what we know. When we throw it up, it's going to come back down at some point, also making a parabola. But let's see where it was thrown upward from. A ball is thrown upward from the surface of Mars. So here's Mars, and if we look at a ground, it's basically horizontal, and it's going to be thrown upward, okay? And it has an initial velocity, okay, of 60 feet per second. So we're going to use the same approach, d grads, okay? So here we have the drawing, and it's going to go up and come back down. Okay, given. What are our givens? Our givens here is that the initial velocity is 60 feet per second. Okay, and we want to know the required is we want to know the maximum height. So that's going to be like this point over here before it starts falling back down. Okay, and then we're going to look at the projectile for Mars. Now Mars has a different gravity. So the other given here, the analysis, I suppose, or the equation that we're going to be using is h of t equals negative 6.5 t squared plus 60t. And what the maximum height? Okay. Well, the v0 is already built into the equation. It's almost like you don't need it. Okay. This is in physics. You learn how to write these equations. Okay. So the equation here is given, meaning this is kind of the givens here are a little bit extra. We don't even need them. And we need maximum altitude. Maximum means, well, if we had just a normal parabola, forget the information. If we had just a normal parabola, a maximum occurs at the vertex, right? So we need to figure out, well, how are we going to get the vertex of this thing? And again, just like for previously defined the x-intercept, so like in the previous problem, we're looking for these points, right, where it's going to land or have 0 height. For vertex, we had a few options. We could put it into vertex form. We could use the memorized, like negative b over 2a, and then plug in negative b over 2a, right? We can do both of the x-intercepts and then find the average, right? Find the axis of symmetry, figure that part out. Other ways we can get the vertex. Any of these will do. So I'm going to try now negative b over 2a. Let's try that form in case you don't remember. The vertexes always look at the negative b. B is the coefficient of the linear term, okay, over 2a, and a is the coefficient of the quadratic term. And then I plug in f of, or in this case h, right, that's h of t. Okay, over 2a.
Mommy, hugs.
Okay, so let's take a look here. So in this equation, a is negative 6.5, b is 60, and notice C here that there's no constant term, 0. Okay, so let's do negative b over 2a. So negative b over 2a would be negative 60 over 2 times negative 6.5. So negative 60 over negative 13. Negative over negative is positive. 13 doesn't have a lot of factors. In fact, it's prime. So there's only to reduce this to. So the x-coordinate of our vertex is 60 over 13. And now I need to plug that 60 over 13 into our original equation to get, if this is the time that it's going to happen, what's the actual height to find that maximum altitude. So let's do this. Look at me a little messy. So h of 60 over 13 is going to be negative 6.5, 60 over 13 squared plus 60 times 60 over 13. Okay, and here just a few options is we need to make sure to follow PEMDAS. Okay, so here we have negative 6.5, 3600 over 13 is 169. Okay, plus 3600 over 13. Okay, and again here we don't have a lot of options. I'm going to write negative 6.5 as 13 over 2. I'll show you in a second why I'm doing that. So negative 13 over 2 times 3600 over 13 times 13. You can use your calculator for this. You don't need to do it this tricky way. I'm just showing you a kind of neat trick there. Plus 3600 over 13. Well, here, if I have it multiplied by 13 over 13, I'm going to get rid of one of those. Check that out. So now I have half of 3600 over 13 plus 3600 over 13, right? So I have a whole, and I'm subtracting half of it. That's not so bad. So the answer is just going to be half of this, which is 1800 over 13. Let me just check my math. Da-da. So looks good to me. Let's clean this up a little bit. 13 to 1800 doesn't go so easily. I'm going to use some decimals here. Let's see what I can do. 13 into 18 is 1. 50, 13 into 50, so 26, 39. That's about as big as go, so we can go 3. 39 is going to be 11, 110. 13 into 110, well, 130 would be 10 times. 9 times would be just bigger than that, so I'm going to say 8. Let's just check that. So 80 and 24 is 104, so that's 6 remaining. 13 into 60. Okay, now we're getting, so it's 138 and change. We can do this on a calculator. I should have thought to bring one, but we're going to figure out this last number, and this would be our vertex. So it's this time, and this is the height, whatever that decimal is. And we look at the units. It was feet per second in our original problem. So our maximum is going to be, this is going to be in feet, and this is going to be in seconds. So at 60 over 13 seconds, the height is 138 and some number of feet. Okay, and this is our vertex, or the maximum height.